Hello, good day, ladies and gentlemen. Welcome to our virtual conference today. It's 1:55 here in Singapore time. I'm Jack. I'll be the host today. I'm from Ringier Trade Media, and as you can see, our topic today is Global Epidemic Control, Challenges and Opportunities for Medical Plastic and Manufacturing. So, if you can hear my voice, please just say hi or have a hello to me. So I can see if everybody sees my hear my voice. Yes, great. Thank you. Hi Jimmy. Hi David. Hi Michelle and hi Mike. Hey. Hi Flips. So very happy. There are actually many people waiting uh, in the waiting room and waiting for this virtual conference to start. This conference will be starting within 3 to 4 minutes. I'll be back later. So see you guys later. Bye bye. Stay tuned. 안 돼요. Hello, good to have me back, right? Due to several reasons, let's wait on still 2 minutes. The official virtual conference today will start within 2 minutes. Thank you. See you later.
Good afternoon, ladies and gentlemen. I'm Andre Sutter, and I work for EMS-GRIVORY, a business unit of EMS-Chemie. This afternoon, I will be presenting Grilamid TR HT 200, the world's
我就和新老朋友一起回顾一下海康机器视觉的发展历程。
今天下午4点，我们还会有一场负重的演讲。
再次感谢谭科长给我们带来的精彩演讲。
我们这一部分内容，我们采取数据缩以及和大数据的方法，
有非常多种的这个工具器件我们可能有很多的这个。
Hello once again. Good afternoon. Here is 2:04 here in Singapore time, and I'm Jack. I'm your host today. I'm from Ringier Trade Media. Hello. So I now announce that our virtual conference started officially. Welcome everybody. Good day, ladies and gentlemen. As I say, I'm Jack. I'll be your host. Welcome you all to our exciting virtual conference. Our topic today is Global Epidemic Control, Challenges and Opportunities for Medical Plastic Manufacturing. This webinar is organized by Ringier Events and supported by our sponsors. First of all, let me introduce you. EMS-GRIVORY, the leading manufacturer of high-performance polymers. And also, Ringier Precision Extrusion Machinery, aka HRJ, specializes in designing, developing, and manufacturing precision extrusion equipment. And also, Guangdong Liangsu Machinery Manufacturing, a high-tech enterprise specializing in R&D and production of plastic extrusion equipment and extrusion discs. This webinar is also supported by International Plastics News for Asia and Medical Manufacturing and Design for China. Okay, as we know, let me proceed. As we all know, the current COVID-19 pandemic has spread. There are more than 8.6 million infected around the world, and death toll of almost 500,000 people. The global economy is in recession as countries move to contain the spread of the coronavirus and its impact on their economics and industrial productions as well. In this current pandemic situation, the role of plastic has become more and more important as critical medical supplies are made of plastics. Today, Ringier event is happy to open the 2-day webinar on the challenges and opportunities in medical plastics production with experts in the various fields related to medical plastics. Please know that today is only the beginning of our informative discussion. Today is day 1, so we encourage you to listen, ask questions, and participate in this 2-day event, 2 days online event, actually. So let me go to this part. May I now remind you everyone that after each presentation, there is a Q&A portion. We encourage everyone to ask questions, and also you can type your questions in the chat box. You can see that in the lower right in your chat area. For today, we have several interesting topics from our expert guest speakers. So now I would like to introduce all our speakers today. Let me give you a quick rundown. Okay, first of all, our speaker, we will have Mr. Prika Bandishvashi. I hope I pronounced his name right. He's the president of Thai Medical Device Technology Industry Association, as ThaiMed. And also, we will be having Mr. Andre Sutter. He's key account manager of EMS-GRIVORY Asia. And the third one, we will have Mr. Edward Shuhatolu. He's SEA Technical Support Manager of Modec 3D. I say hi, hello, welcome you. Yeah. And also, last but not least, we will have Mr. Joy Roy Bondok. He is Senior Research Manager of Collier International Philippines. And due to the speaker's arrangement, let's move to our agenda. We have a little bit change here today. I would like to introduce this one. As I say, for the first session, we will have 2 speakers. For our schedule is Mr. Prika Bandivesh and also Mr. Andre Sutter. And we will have a tea break time for 10 minutes. And in our session 2, we will have Mr. Andrews Suhatadu and Mr. Joy Roy Bonak. But due to several reasons, we will have Mr. Joy Roy Bonak talk as our first speaker today. So at each presentation, we would love to invite speakers to have 5 to 10 minutes for the Q&A time, as I said a while ago. So feel free to ask those questions in the chat room. And also, we will have our lucky draw today, as you can see at the very last section of our agenda. We will have a lucky draw, and our prize will be the free VIP ticket pass of our hybrid event. So it's very exciting. So please stay until the lucky draw, and you may win the prize. We will have 3 lucky attendees today to win the prize. So before any speakers have their presentation first, before we start off, I would like to give some tips to our participants to how to use this meeting room. So there are several tips today I would like to share. Small tips for the virtual conference today. For example, how to move the speaker's photo, how to leave a message, how to translate the foreign language message in the chat room, and so on. I'll introduce them one by one to you. So first of all, let's see how to move the speaker's photo. If you can see my photo is there, I mean upper right, which is your right, there, right? Okay, you can move the speaker's photo wherever you want by clicking the button of the duck button, and also you can use your mouse, drag my photo wherever you want. You can now try to use this function because while our speakers have their presentation, maybe my photo or our speaker's photo will have their blocking the area of the presentation. So feel free to move wherever you want. But also, you would like to see our speakers' vivid presentation. While they do their presentation, also show their faces, right? So take note of these tips. And next one, how to leave a message. I see there are many people leaving a message there already, but I encourage more people to leave the message and also ask questions there. I would like to see more questions to challenge our speakers today. Okay, I'll see who left the greatest question today. So, also related to the chat room function, please take note that if you ask any question with the question mark and ending of your sentence, you can see the question will turn into a message that I can publish in the center of our presentation area. So if you ask any questions in the chat room, I will be there to publish those questions and ask the speakers to answer the question to you. So everybody can see that their question will be focused in the center of our stage. The next step, let's see how to translate for the foreign messages. This is very important. If you see any foreign language, or even you want to translate those English messages into your local language, you can use this function. Go to the gear button. You see, there's a gear button upper right at the chat room, right? You can see. Scroll down, please. The last one function is translation. You can one-click the choose language function and choose any flag, national flag or language you want to translate. Every message in the chat room will just go into, just turn into the language you choose. Try it. This is really, really interesting and very useful function. And also for our speakers, if our attendees ask the question in their local language, in their mother tongue, they can also translate those language into the speaker's language. So let's move on. Our next tip will be how to turn a camera or microphone on. You can see if during the time as a speaker or attendee would like to show their face, ask a question by their in person, I will share the authority as the presentation to give you the right to turn on the camera and microphone. So the next tips will be how to raise the hands. This is very funny. You can see there will be a palm icon, and you can see if one click with the palm icon, you can see there are 6 functions there. Raise hand, agree, disagree, or ask speaker to speak louder, speak softer, and simply put I need help. So there will be many assistants there, also from Ringier Media, answer your questions too. And also you can ask the speaker to speak louder or speak softer, maybe. Yeah, you can use that, show your status. Now, I would like to see if you understand my introduction. Give me a thumb up, please. Give me I agree sign. Yes, that's it. Thank you very much. I see many people give me a thumb up. I'm very happy. Thank you.
Good afternoon, ladies and gentlemen. I'm Andre Sutter, and I work for EMS-GRIVORY, a business unit of EMS-GRIVORY. This afternoon, I will be presenting Grilamid TR HT 200, the world's first steam sterilizable transparent polyamide. The build-up of this presentation is as following. First, I will give a brief introduction to EMS-GRIVORY, followed by an introduction of Grilamid TR, including our newly developed Grilamid TR HT 200. Here we'll compare properties of our main Grilamid TR grades to each other, as well as other common amorphous transparent materials. Then we will look at the steam sterilization performance of our Grilamid TR HT 200 and show some target applications for this grade. Last but not least, I will show some reference applications for Grilamid TR in the medical and healthcare sector. EMS-GRIVORY is part of the EMS Group, a multinational company headquartered in Switzerland with our main production in Domet EMS shown on the left above. On the right-hand side, we show our regional headquarters for Asia in Suzhou, China. Key figures for 2019 are as following. Our net sales were just over 2.1 billion Swiss francs. EMS was founded in 1936, meaning we will celebrate our 85th anniversary next year. Total employee numbers is around 2,650, and we have 26 production locations in 16 countries. EMS-GRIVORY business unit is a leading manufacturer of high-performance polyamides with over 30 years of experience. Our activities solely focus on polyamides, and we can boast to have the widest range of different polyamide product families out of all the polyamide manufacturers. We are active worldwide, we are prompt, and we are customer oriented. We have a strong focus on application development, being able to coordinate and support any development globally. Our main focus is to be a development partner for our customers, offering them cost and weight saving solutions. Moving on to Grilamid TR. Grilamid TR grades are amorphous thermoplastics based on polyamides. Because Grilamid TR is amorphous, it displays glass clear transparency, and because it is based on polyamide, it also displays high chemical and stress crack resistance, good flexural bending strength and mechanical properties, as well as a low density. Grilamid TR is unique in the fact that it is an amorphous, transparent material which exhibits the three main requirements, these being transparency, the obvious one, good mechanical properties such as dynamic strength and fatigue resistance, with the third one being chemical and stress crack resistance. In comparison, the other amorphous transparent materials only exhibit one or two of these main requirements. So when it comes to demanding applications which require all three requirements, Grilamid TR is the only choice. On this slide, we look at what we call the polymer triangle, where on the left-hand side we have our semi-crystalline products and on the right-hand side our amorphous products. At the bottom of the triangle we have our high volume, low cost, low performance, in the engineering sense, materials such as polyethylene and polypropylene, commonly known as commodity products. Moving up, we come to the engineering plastics, which are materials such as polyamide 6, polyamide 66, as well as PET, PBT, POM, polycarbonate, acrylic, and so on. And at the top, we have our high-performance plastics, including materials such as PPAs, which are high-temperature polyamides, PPS, various sulfones, and PEEK. With our Grilamid TR range of products, we cover the top end of the engineering plastics up into the high-performance plastics as shown by the red circle. Following are the main products in our Grilamid TR range. Grilamid TR30 is a high stiffness grade with a good scratch resistance. Then we have our Grilamid TR90, which is flexible and tough, has excellent chemical resistance and a high fatigue resistance. Grilamid TR55 is what we refer to as having a balanced property profile between flexibility and stiffness. This grade also exhibits the best hot water resistance out of our TR grades. Last but not least is our newly developed Grilamid TR HT200. This grade has the highest glass transition temperature out of all our TR grades, providing good thermal resistance, making it suitable for repeat steam sterilization use, and is suitable for silicon overmolding applications. In this slide, we compare our different Grilamid TR grades in regards to key properties. It is important to note here that this is a ranking against each other, and if any grade gets just one positive symbol, it does not mean it's poor in that property. For the chemical resistance, the best grade is TR90, followed by TR55 and TR HT200, then TR30. For the toughness and stiffness, generally the higher the stiffness, the lower the toughness. although TR30 is an exception here as it has good toughness despite having the highest stiffness. The heat deflection temperature, or HDT, is dependent on the glass transition temperature. TR90 has the lowest HDT as it has the lowest glass transition temperature of 155 degrees, compared to Grilamid TR HT 200, which has the highest glass transition temperature at 200 degrees. For the processing, they're pretty much all the same. However, the TR90 does have a slightly wider processing window compared to the other grades. For the next two, steam resistance and boiling water resistance, you would think they are similar. However, there are different dynamics at work here, so we don't have the obvious ranking. In regards to steam sterilization at 134 degrees Celsius, the TR HT 200 displays the best resistance. However, in regards to boiling water, then the TR55 is the best material. In regards to the pricing, the higher the number, the higher the price, but fortunately not proportional to the numbers. On this slide, we compare our Grilamid TR grades to other transparent amorphous materials in regards to the glass transition temperature on the horizontal axes and the E modulus, i.e. the stiffness, on the vertical axes. Here we see that our TR90, TR55 and TR30 grades all have a similar glass transition temperature varying between 155 to 160 degrees Celsius, but with the different stiffness. These three TR grades are in the same range as polycarbonate. If we consider acrylic, PETG and PETA, we see they have a much lower glass transition temperature, making them unsuitable for applications where thermal resistance is required. At the other end of the scale, we have sulfones such as polyphenol sulfone and polysulfone, as well as PEI, which range in glass transition temperature between 190 to 215 degrees Celsius. These grades are also stiffer in the range of about 2,500 to 3,200 megapascal. Our Grilamid TR HT 200 sits pretty much in the middle in regards to the glass transition temperature at 200 degrees Celsius, but with a slightly lower stiffness of 2,300 megapascal. For the transparency, we will consider glass as a reference. Generally, glass has a transparency of 90% measured at 540 nanometers and at a thickness of 3 millimeters. Polycarbonate and polysulfones are slightly below the value of glass, whereas Grilamid TR exhibits the same high transparency as glass. Only acrylic or PMMA is better than both glass and Grilamid TR. This next slide shows the density, which is often overlooked as an important property. However, the density is relatively important as it has a bearing on the cost of the part. Basically, the lower the density, the more parts can be molded out of a given amount of resin. Further to this, we can also produce parts with lower weight, which is important when it comes to wearable items such as hearing aids, masks, and wearable electronics. The amorphous transparent materials, excluding Grilamid TR, range in density between 1.17 up to 1.24, whereas the Grilamid TR grades range between 1.01 up to 1.06, excluding the Grilamid TR30, which sits at 1.15. Here we compare Grilamid TR and other transparent amorphous products, polysulfone, acrylic, and polycarbonate, against the main chemical groups, solvents, alcohols, benzenes, mineral oil, alkali, and acids. For the ranking, a hollow circle means there is no resistance. A half circle means partial resistance, meaning it can withstand limited contact, and a full filled in circle means it has full resistance. If we start on the right hand side, we see that polycarbonate and acrylic have relatively poor chemical resistance, not really showing any good resistance against the main chemical groups. The polysulfone is considerably better, however has problems with solvents. The transparent amorphous grade with the best chemical resistance is Grilamid TR, which overall shows a very good resistance, with the only Achilles heel being acids. Here we have a slide more relevant to the medical and healthcare segment in regards to chemicals used for cleaning. Here we measured the resistance against commonly used branded cleaners such as Byrex, Cavicide 1, Sidex OPA, and so on. The chemical resistance was measured according to ASTM D543, where the test bars were under 1% strain. The different materials were judged as following. After exposure to the chemicals, we measured the tensile strength comparing the before and after value. A hollow circle means the tested material had a retention of tensile strength of 69% or less. A half circle represented a retention of 70 to 94%, and a full filled-in circle representing above 90%, basically meaning no significant loss of tensile strength was measured. If we look at the polymer materials tested, let's start with the bottom three: polycarbonate, ABS, and a polycarbonate ABS blend. Here we can see that all three of these grades show a poor resistance, excluding a few exceptions. On the other hand, Grilamid TR and Grilamid TR HT 200 have an excellent resistance for all tested cleaners apart from IPA at 70%, where we have limited resistance. On this slide, we compare three main Grilamid TR grades with PC, polyphenol sulfone, and polyether sulfone. Judging here is that a red is negative is poor, a hollow black circle is okay, and the plus symbol is good. For the transparency, they all show a good transparency apart from the sulfones, polyphenol sulfone and polyether sulfone. Their transparency is affected by their dark yellow brownish color. The next two positions show whether the material contains bisphenol A and bisphenol S or not. These are chemicals used in the manufacture of some materials, which can seep from the plastic container into food or beverages. Exposure to bisphenol is a concern because of possible health effects on the brain and prostate glands of fetuses, infants, and children. Initial concern was with BPA, however in recent years BPS has also come under the spotlight. Today, bisphenol-containing materials are generally no longer being used for infant care products, and many manufacturers are going away from them for any food or beverage contact applications. Whether bisphenols should be considered as a concern or not is still being debated. However, with Grilamid TR, we provide grades which are both BPA and BPS free. For the chemical resistance, they all show a good resistance apart from polycarbonate. Density, here, Grilamid TR shows a clear advantage, as seen in previous slides. For the boiling water resistance, Grilamid TR, except TR30, shows comparable results to the other products. For steam sterilization, at 134 degrees, generally Grilamid TR shows a poor resistance. However, with our TR HT 200, we have developed a clear polyamide which has superior resistance when comparing against polycarbonate and sulfones. For bonding to LSR, or silicon, a growing requirement in the medical and other applications, Grilamid TR shows a good ability, with the TR HT 200 showing the best ability due to its high glass transition temperature and corresponding higher heat deflection temperature, allowing higher curing temperatures of the silicon, considerably improving production cycle times. Sulfones, on the other hand, generally have poor adhesion to silicons. In regards to processing, the Grilamid TRs show a clear advantage over the sulfones due to the higher processing temperatures required for sulfones. Here we have a further comparison shown on a graph. This graph also includes the stiffness, strength, and toughness, and we have also taken in a PEI, the green line. The general picture of this graph is that Grilamid TR HT 200, the light blue line, shows an overall consistent high performance against the listed properties. Other materials may perform slightly better in certain areas, but overall the Grilamid TR HT 200 has the best overall performance. Coming to the approvals, here we have an overview of our main Grilamid TR grades and the corresponding food contact and medical approvals. Both TR55 and TR90 have all the main approvals, with Grilamid TR HT 200, having already gained the Usp Class 6 and ISO 10993 approval, with EU and FDA food contact testing under testing. At this stage, we have not yet tested the TR HT 200 for the Chinese FDA approval. A brief note to the TR30, this grade has not been put forward for approval testing, as we have grades such as the TR55 and TR90, as well as the TR HT 200, which have these approvals. On this slide, we can see that all Grilamid TR grades have a good resistance against the common sterilization methods such as ethylene oxide, gamma irradiation under 40 kilorad, and hydrogen peroxide at 50 degrees Celsius for 54 minutes. However, where Grilamid TR and other transparent polyamides have fallen over in the past, is for repeated steam sterilization at 134 degrees, a common sterilization method in the medical and healthcare sector. With the development of our Grilamid TR HT 200, EMS-GRIVORY has developed the world's first transparent polyamide with the ability to resist repeated steam sterilizations at 134 degrees up to 500 cycles. Here we look at the steam sterilization resistance in more detail by comparing the notched impact strength of Grilamid TR HT 200 against PEI, PESU, and polysulfone, materials currently being used for repeated steam sterilization use. Steam sterilization process used for this was 134 degrees for 18 minutes with a 90-minute cool down period before the next cycle. The first obvious point is that Grilamid TR HT 200 has a notched impact twice that of the other products, sitting around 14 kilojoules per meter squared, giving it exceptional toughness. At the steam sterilization cycle start, we see a slight dip over the first 50 cycles, after which the curve flattens out again. After 500 cycles, we can see that we still have an impressive 12 kilojoules per meter squared notched impact value, basically showing us that the steam sterilization process does not have any significant negative effect on the mechanical properties of the Grilamid TR HT 200, even after 500 cycles. Also, in regards to the color, we do not see a significant change after 500 cycles. On the left-hand side, we have a photo of before sterilization. Here we can see that it has a slight yellow tinge to it, which is inherent to polyamides. This, however, can be compensated by adding a blue master batch, which basically neutralizes the yellowness and allowing a neutral or water-clear solution. On the right-hand side, we have a photo of after 500 cycles. Here we can see that the yellowness has slightly increased, but the TR HT 200 is still fully transparent without any sign of haziness or distortion. Looking at target applications for our Grilamid TR HT 200, we're predominantly pushing this grade towards applications which require repeated steam sterilization, such as suction pump jars, anesthesia masks, artificial respiration valves, and flow meter bowls. Further applications are baby bottles and medical films, and any components which uses or is considering to use silicon in an overmolding process. Now we move on to the reference applications for Grilamid TR in the medical and healthcare sector. The first one we come to is for a closure system for laparoscopic surgery. In this case, Grilamid TR was chosen due to its ability to withstand the required sterilization process. Secondly, the low density allows for a lightweight item, making it easier to be used by the surgeon or nurse. Further to this, we have its good chemical resistance and good mechanical strength and toughness. Here, both the white and clear parts are out of Grilamid TR. The Grilamid TR can be colored to any solid or transparent color. Further to this, with Grilamid TR being an amorphous product, it has a very low warpage and differential shrinkage, resulting in easier processing. Here we have a bone cement delivery system. The reason Grilamid TR was chosen are similar to the previous example in regards to mechanical strength and toughness and chemical resistance. In this case, we require a good resistance against the bone cement, which is quite aggressive. On the right-hand side, we can see how this bone cement attacks polycarbonate, making it unsuitable for this application. Another reason Grilamid TR was selected for this application is its medical approvals, in this case Usp Class 6 approval. This application for a non-invasive breathing mask takes full advantage of all the benefits of Grilamid TR, like bisphenol-free, lightweight, chemical resistance, high heat resistance up to 170 degrees, especially suitable for silicon overmolding, allowing the curing time to be reduced, as well as good adhesion to silicon with a pull force of over 70 newtons. And last but not least, the Usp Class 6 approval. As you can imagine, this application has ramped up considerably over the last 6 months with the spread of COVID-19. Hearing aids is quite a sizable application for Grilamid TR. The reason why Grilamid TR is being used by several hearing aid manufacturers is due to its high chemical and stress crack resistance. Even chemicals such as skin moisturizers, perfumes, and hairsprays can cause issues for amorphous materials, but not for Grilamid TR. Approval for skin contact, easy processing, and high flowability, as well as low warpage due to the fact Grilamid TR is amorphous. Last but not least, it has low density, allowing for a very light hearing aids, improving the comfort to the wearer. A further recent development has been our PA sanitized grades, which are grades preventing bacterial growth on the surface of components made out of polyamide. These grades have shown to eliminate over 99% of surface bacteria according to the test method JIS Z2801 2010. These are compounded grades based on different polyamides, including a range based on Grilamid TR. One note of caution is that the additive used to achieve this antibacterial property has a negative effect on the transparency, making it not possible to have highly transparent parts. Summarizing what I've presented over the last 20 minutes, Grilamid TR has a very good chemical resistance which is superior to other transparent amorphous grades. It has a high toughness, high clarity and transparency comparable to glass. We have medical and food approvals as well as being bisphenol free. It's reusable instead of disposable, improving sustainability, and the lowest density out of all the transparent amorphous grades. On top of this, with our new Grilamid TR HT 200, we have developed the world's first transparent polyamide for repeated steam sterilization applications. Last but not least, I just want to inform you about Emsa's development support. EMS can offer design concepts in regards to design proposal and part cost calculations. After this, we can support you in material selection and design evaluation using your own experience gained over the 30 years EMS has been developing applications with specialty polyamides, backed up by the latest simulation programs. Development support is done on a global level with coordination and support between our technical centers in Asia, Europe, and North America. So no matter where your next product is designed, developed, or manufactured, EMS can support you throughout the whole process. With this, I now conclude my presentation. Thank you for your attention. Please feel free to ask any questions.
Hello, can you hear my voice, Mr. Andre Sutter?
I can. I hope you can hear mine.
Yes, I heard you loud and clear. If anybody can also hear me and Andre Sutter, please say hi or say yes. Greet to our speaker. Welcome our speaker, Andre Sutter. Yes, I see people typing. Thank you. Mr. Sutter, great presentation. I see there are several questions there and asking you questions. Should we go one by one with them?
Please do, yes.
We have at least 4 questions there already for you. Let me publish this question. This one is from Jenny Lu. Can you read the question? And can anybody read that too also? Besides cost and waste saving through metal replacement, what are the unique solutions EMS also provide? Oh, this is a good question for EMS.
one of the other unique solutions is exactly the Grilamid TR, which I've just presented. So this is a transparent nylon. It can be used for glass replacement, but it's also here to be used as a reusable material. Instead of disposable plastic components, we can make them reusable, as the Grilamid TR can be sterilized, is chemical resistant, therefore has got long-term use capability.
Yeah, great. And also, Sutter, let me remind you that you can talk to with your microphone more near, yeah, a little bit. We'll make your sound louder, yeah, like this.
Okay.
Yes, yeah, that's so
That's
much better. Yeah,
Sorry.
great.
Yep.
Yeah, so I hope that answered your question, right, Jenny? I think that's a short but really great answer to you, maybe. Yeah. So let me publish the next question, okay? This one, Richard, is that okay for you to answer that? Are there any special consideration needed to mold the H2 200?
No, the Grilamid TR HT 200 can be molded as any other nylon or polyamide, as long as the extruder or the injection molding machine can reach temperatures of 300 degrees, and we have mold capabilities of up to 100 degrees, then there are no special requirements needed to process the TR HT 200.
Great. And also this one, at the end of the product life, how do you dispose of the product? Can it be recycled back? Oh, the great question. We all concerned about recycling, right? Hello, Sutter?
Yeah. Grilamid TR
Yeah.
is a polyamide and therefore is a thermoplastic, meaning it can be remelted and reused. However, since the Grilamid TR is a transparent material, we do not recommend to recycle it to a further transparent application, as there's often contamination which comes into the recycling stream. It can be recycled into a secondary product, predominantly which is then colored but not transparent.
I see. Yeah. Also, we don't want to make yeah, any bad outcome, right? And the next question, is this suitable for additive manufacturing? Oh, great question, Chris. This is the trend now, right? I mean, the 3D printing.
Are we talking about 3D printing, or are we talking master batches here?
I'm not sure.
If we're talking master batch or additive adding, then yes, the Grilamid TR is suitable, as a lot of the additive master batches we have for our Grilamid TR ranges, like a blue master batch, a UV master batch, or other additives, they are based on the carrier Grilamid TR. So yes, it is a product that can be compounded or used to compound additives into it.
I see. Yeah. Thank you for answering and also teach me something. And also this question, for this one, you can read this question from Taiwan, right? Oh, no, not from Taiwan. It's from Tan Wei Car.
For adhesion to LSR, that is silicon rubber, it means a chemical bond. Yes,
Yeah.
we have a certain chemical bond to LSRs. However, you need to select the correct LSR grades, and you need to talk to your LSR manufacturer for suitable nylon bondable LSR grades.
I see. So, excuse me, Mr. Sutter. I see the attendee asked for the extended question already. He's asking for 3D printing, actually.
As with any transparent material, 3D printing is very difficult to obtain a good transparency afterwards due to the 3D process. So we cannot get the same transparency with 3D printing, but the remaining properties, the chemical resistance, will be similar as it is inherent to a polyamide. Answering that question, yes, it can be used for 3D printing, but we will not get the transparency or the glass clear transparency.
Yeah, I see. Yeah, thank you for that. I hope this answer your question. Okay. So our next question will be, as the material is polyamide. Yeah, I pronounced the wrong way later before. How is the stiffness property comparing to polycarbonate?
Right. In one of the slides where we compared the glass transition temperature and the stiffness or the modulus, we had the Grilamid TR, Grilamid TR 55 and TR 30 in the same range as polycarbonate. So polycarbonate has a stiffness or an E modulus of about 2,300 megapascal, whereas the Grilamid TR 55 has a E modulus of 2,200. So they are very close to each other.
Oh, that's why. I believe we have one last question. If you want, we can finish all the questions here to answering all
If we
the
have
questions.
time, certainly.
Yeah. Oh, this is a long question. You try to read it for our audience, please.
Due to high demand for weight reduction, industry is looking for innovative process like foaming and injection molding. Which grade of polyamide from EMS-GRIVORY is compatible with such foam process? This presentation focused more on the Grilamid TR, the transparent material. We do have grades that can be foamed, but if you want to contact me on my email later on, I can provide you more detailed information on those materials.
I see. That's all the questions shown in the Q&A mode, but I believe there's a question raised by Lay SH, and because he or she didn't use the sentence with the question mark ending, but I believe that's a question too. So maybe we don't overlook it. This one.
Okay.
What's the price comparison? Tricky question, huh? So maybe simple answer only. Yeah.
Right. Nylons or polyamides in general are considerably more expensive than polypropylene, as polypropylene is more considered as a commodity product, whereas the polyamide is an engineering plastic. The Grilamid TR is at the upper end of the engineering plastic range, therefore the price is considerably higher than polypropylene.
Okay, great. Once again, thank you, Mr. Andres Sutter from EMS-GRIVORY. And I believe that, yeah, thank you for answering those good questions. And you also taught me a lot through your presentation. And I believe that if you have any further question, please just contact us later. And also, I would like to remind all our audience, you can go to the upper right corner, the event board, and if you click the share files, you can see more information, or the document you can download later by yourself. You can read later and contact us for details or further questions, right? So anyway, thank you, Andres Sutter, for your time today. Great presentation. Thank you.
Thank you.
Bye-bye.
Bye-bye.
Yeah, maybe say goodbye to our audience. Yeah. Bye-bye.
Thank you.
Thank
Bye.
you. Thank you. Thank you for your time.